One of the most anticipated cosmic events is the explosion of Betelgeuse, a red supergiant star located on the well-known shoulder of Orion. Approaching the end of its life, Betelgeuse, one of the brightest stars in the sky, began to dim noticeably in 2019. This dimming was so prominent that it could be observed without specialized optics. For a few months, Betelgeuse faded until spectators wondered if the star had died. When researchers focused their most powerful telescopes on this red giant, they were shocked to see evidence of this incredible dimming, even though the star's brightness had returned to normal after a few months. This star is on the verge of exploding as its life cycle nears completion. But when and why might a supernova occur, and would it have tragic consequences for Earth? Let's explore. The brilliant ruby-red star Betelgeuse is located on the upper right shoulder of the winter constellation Orion, the Hunter. You might know it better by its alternative name, Alpha Orionis. It is the second brightest star in the constellation, directly behind the blue supergiant Rigel. Betelgeuse is a fascinating target for astronomers to observe and study due to its variable behavior and peculiar name. Alpha stars are usually the brightest in their constellations, and this is generally true even though Rigel, Orion's other great star, shines brighter. Thanks to its brightness, size, and ruddy hue, Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the sky. It is the 10th brightest star in the sky and the 7th brightest star visible from most of North America, Europe, and Canada. The name Betelgeuse originates from an Arabic word meaning the armpit of the giant, which is a frequent interpretation of the name. Betelgeuse's actual distance from Earth is unknown, but scientists estimate it to be between 430 and 724 light-years away. In short, Betelgeuse is the brightest and nearest red supergiant star to Earth. There are only about 200 red supergiant stars known to exist in the Milky Way. Betelgeuse is around 764 times the Sun's radius in width, producing 126,000 times as much light as the Sun and visible from a distance of approximately 548 light-years. It is cooler than the Sun, with a surface temperature of 3,600 Kelvin. Roughly 13% of Betelgeuse's total radiant energy consists of visible light, but it would be even brighter than Sirius if we could see light at all frequencies. If Betelgeuse replaced the Sun in our solar system, its reach would extend past Jupiter and the asteroid belt, engulfing Earth, Mars, Mercury, and Venus entirely. Betelgeuse, a red supergiant, loses about 1 solar mass every 10,000 years, as material is ejected unevenly from the star in all directions, creating a cloud around it. This cloud stretches approximately 30 astronomical units, AU, or 30 times the distance between the Sun and Earth and is much larger than Betelgeuse itself. At its core, a star's hydrogen atoms fuse under the influence of gravity, creating helium in a nuclear reaction that releases heat and light, two forms of energy produced abundantly during this fusion process. This energy travels to the star's surface, eventually escaping as photons into the universe. Eventually, the star will exhaust its primary fuel, hydrogen, and must rely on helium and carbon for burning. When all the helium has been used up, neon will interact with carbon to create iron. When this happens, the energy produced by the fusion of neon and iron is absorbed. As iron builds up within the star, its high gravity causes it to collapse in on itself, triggering a supernova explosion with the force of 10 billion suns. A supernova is one of nature's most powerful explosions. Depending on their age and evolutionary stage, stars emit light of varying wavelengths and temperatures, resulting in a spectrum of colors, from the blue of the youngest stars to the red of the oldest. According to Ptolemy, a Greek scientist who lived from 90 to 168 AD, Betelgeuse's color was unusually described as bronze. However, ancient Chinese astronomers noted that Betelgeuse appeared yellow, suggesting that it might have been a yellow supergiant in the past. Larger stars often burn there. Hydrogen fuel burns all the more rapidly, prompting the possible end of some stars regardless of whether they are just approximately 10 million years old. Irrefutably, Betelgeuse is in its last stages of existence. However, at over 5 billion years old, our Sun is still going strong. The star Betelgeuse is approaching the end of its existence, which means it may go supernova at some point. However, the exact timing of this event is highly controversial. There are two patterns of dimming and brightening that occur on Betelgeuse, the second of which happens at regular intervals and lasts for around 100 days. There's a supposition that the star's outer shell expands and contracts over this cycle, causing its diameter and average temperature to change at each stage. Many people focused on Betelgeuse due to its unpredictable dimming in 2019 and 2020, followed by a brief recovery to its usual brightness. Some astronomers have speculated that it could mean the star is dying. Extensive studies of Betelgeuse date back to the 1st century BC. However, the cause of its sudden and abnormal dimming remains unknown. Betelgeuse was observed speeding across the interstellar medium at a rate of 30 kilometers per second after being ejected from its birthplace in the Orion OB1 association, which contains the stars in Orion's belt. A bow shock from this speeding star spans more than 4 light-years across. Distances to red supergiant stars like Betelgeuse are notoriously difficult to calculate in astronomy, with many factors complicating efforts to determine its true size. Betelgeuse's diameter changes over time as it pulsates, and because of limb darkening, the star's visual emissions change color and fade as one moves from its center. When trying to define Betelgeuse's photosphere, it's important to account for the circumstellar envelope, which is made of material ejected from the star that both emits and absorbs light. Making direct comparisons between observations is challenging due to the star's apparent size changing with frequency. Diameters can vary by as much as 35%, depending on the frequency used to measure them within the electromagnetic spectrum. In July 2009, the European Southern Observatory released images taken by the ground-based Very Large Telescope Interferometer, VLTI, which showed a massive gas plume extending $30 from the star into the surrounding atmosphere. This was one of several mass ejections from Betelgeuse's atmosphere, with a size comparable to the distance between the Sun and Neptune. At least 6 shells have been found by astronomers surrounding Betelgeuse. If the mystery of mass loss in the dying stages of a star's life could be solved, perhaps the reason for these giant stars' dramatic demise could be uncovered. Betelgeuse's extensive atmosphere and its complex dynamics have been studied. However, the specific mechanism by which material is lost from red supergiants remains unknown, though it's crucial to the recycling of matter that forms galaxies. Thanks to recent advances in interferometric techniques, astronomers may soon find a clearer answer. Specialists used Hubble and different telescopes to find that in 2019, the star dismissed an enormous lump of its visible surface and released a significant surface mass ejection, SME. Coronal mass ejections, CMEs, happen frequently when the Sun sheds portions of its volatile outer atmosphere, the corona. However, the force of these events is thousands of times lower than what was observed on Betelgeuse. The surface mass ejection from Betelgeuse expelled 400 billion times more mass than a typical coronal mass ejection, explaining why Betelgeuse began to dim rapidly in October 2019. By mid-February 2020, its brightness had decreased approximately threefold, from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had stabilized for over a week. By day 5, it appeared that Betelgeuse had stopped dimming altogether, effectively ending the dimming event. Ongoing visual dimming appears unrelated to an impending core collapse, as there were no significant changes in the infrared on February 24, 2020. Another study published around the same time concluded that large-grain circumstellar dust was likely responsible for the star's dimming. The study used submillimeter wavelength measurements to rule out dust absorption as a major contributor, suggesting large star spots were likely the cause of the darkening. A closer look showed that Betelgeuse's luminosity had significantly increased. The new, dramatic drop in Betelgeuse's brightness was linked to the discovery of a second dust cloud emerging from the star on August 30, 2020. A cool region on its photosphere was identified as the dust source in June of last year, and in August, a second independent assessment confirmed the initial findings. The expelled gas from the star cooled, forming the dust cloud. Studies from the Hubble Space Telescope in 2022 showed that, thousands of kilometers from the star's surface, the material expelled cooled and condensed to form the dimming dust. Betelgeuse's photosphere, which is several times the size of our moon, broke apart and drifted into space, obscuring the star from Earth. This dimming, which began in late 2019 and lasted for a few months, was noticeable even to amateur stargazers. The supergiant's pulse rate, which has been stable for 400 days, stopped during this event. To monitor this cycle, astronomers have tracked Betelgeuse's surface movements and brightness variations for over a century. The explosion's intensity is reflected in the damage, as cosmologists theorize that the disturbance could explain the anomaly. The star's photosphere is also regenerating, gaining strength over time. Betelgeuse's internal structure vibrates like a broken bell as its natural cycle is disrupted. These findings shed light on how red stars age and lose mass before their nuclear fusion furnaces deplete and they explode as supernovae. The fate of these stars largely depends on how much mass they lose. Betelgeuse's unusually aggressive behavior does not necessarily indicate the star's impending supernova, and scientists believe that a massive surface mass ejection has never been observed in a star, suggesting there is something we don't yet fully understand. Hubble can help us detect discernible surface features like this ongoing phenomenon of star evolution, revealing an unseen phenomenon. Interestingly, the expelled material's infrared radiation is still escaping from the star, so it could potentially be detected by NASA's James Webb Space Telescope. Finally, Betelgeuse's dimming has ended, and it may once again become the 10th brightest star in the night sky. Betelgeuse, despite its enormous size, remains one of the brightest stars in the sky, shining almost 100,000 times as brightly as the sun. To maintain Betelgeuse's immense energy demand, it must burn fuel quickly, accelerating its eventual collapse. When the star runs out of fuel and collapses under its own weight, it will explode in a spectacular supernova. For a few weeks to months, Betelgeuse will become extremely bright, potentially reaching levels comparable to the full moon. When might this happen? It's uncertain. While we may not witness it in our lifetimes, it could occur tomorrow or in tens of thousands of years. Will Earth be affected by Betelgeuse's supernova? Because Betelgeuse is so far from Earth, its explosion won't harm or even significantly impact life here. According to cosmologists, the safest distance from a supernova for human life is 50 light-years, making Betelgeuse more than 10 times farther away. Instead, everyone on Earth will get a visual display when a very bright star suddenly appears in the sky. Please share your thoughts in the comments. Thank you for watching this video until the end. If you like this video, like and subscribe for more content like this. We have another very intriguing video ready for you. Click on the video on your screen, and let us take you on another stunning space adventure.